take a look at what's important and what's not important. Blah, 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 not important. These fellas, hafal yourself. I have no reason to teach you all this. This one, don't waste your time. I mean, I'm not going to waste you all your time. Hafal yourself. All these old people by yourself, you have to remember. See all this? All these old people, you sendiri kena hafal. I'm going to go straight into arrangement of the periodic table of elements. Okay, so let's take a look first. Remember, when you go this way, it's called group. Group 1, 2, 3, 4, 5, 6, all the way to 18, okay? That is group. Period is period 1, period 2, period 3, period 4, period 5. Now, what's the difference between group and period? Okay, in one group like this, all similar characteristics. But when you go across like this, they are different groups. See, this one alkaline metal, this one alkaline earth metal, this one halogen, this one noble gas. Yes, they are all a part of period 4. Okay, they are all a part of period 4, but their characteristics are different. So, that is for period. So, for period 4, when you go across, same period but different characteristics. Let's say group, maybe I pick group 18. Okay, I'm going this way, I'm going down. Same group, similar characteristics. So, the groups are the ones that have similar characteristics. The period, no. Period, different characteristics. Okay. All 118 elements, ascending order of proton number from left to right. Look here. Proton number 1, 2, 3, 4, 5, all the way until wherever down here. Okay, 118. All the way until there. Now, see what I told you? Vertical column is group. Similar chemical properties arranged in the same group. Okay, and group also have, see, same group, same number, valence electrons. So if you are in group 1, the alkali metals, you have 1 valence electron. If you are in group 18, okay, noble gases, you have 8 valence electron. So let me explain. This is group 1, 2, 3 to top is here, then 13, 14, 15, 16, 17, 18. Now, in purple, I'm going to write the number of valence electrons. Okay, group 1, 1 valence. Group 2, 2 valence. Group 13, 3. Group 14, 4. Then group 18, 8. Okay, purple is the number of valence electrons. Okay. Now we move on to the remainder characteristics. Horizontal row is period. What does it mean? Same number of shells occupied with electrons. Means what, guys? Not same number of electrons, not same number of valence electrons either. It's same number of shell. Like sodium is 2, 8, 1, 3 shell. Magnesium 2, 8, 2, also 3 shell. So everything here, I use blue, okay? Everything here has 3 shells of valence electrons, okay? 3 shells. But the number of valence is different. Like here, 1 valence, 2 valence, 3 valence, 4 valence, all the way until 8 valence. So, one more time. Going down in a group, same number of valence, different number of shell. In a group, same valence, different shell. Now going across a period, not a group, a period. Different valence, same shell. You guys understand the difference or not? Guys, remember, I can't see the chat box. You have to open your mic. If you cannot open your mic, maybe Rishabh can help me read out who's saying anything in the chat box. You guys understand or not? Okay, Bibulan. Lakshan, how? Okay, Chun. Alright, so here's the group name and all. Okay, just hafal this. I put star. Okay. Now, which atom is a halogen for this one? Sorry. Which one is a halogen? It is Z. Kenapa? All halogens have 7 valence. 1, 2, 3, 4, 5, 6, 7. I should not have made that dumbass joke. I'm sorry. Anyway, remember, all halogens have 7 valence electrons. Right? So answer is D. Okay, now moving on. Second question here. Alright. What is the position of element X in the periodic table? So when they ask you for position, they want to know group and period. How do we know it's D? Let's check. 1, 2 shell. 2 shell, confirm period 2. So it's either one of these. Now, 1, 2, 3, 4, 5, 6, 7, 8. 8 valence means group 18. So your answer is D. Okay, moving on. Let us take a look at this. Okay, this one, let me see if there's anything important. No, this one we can skip. Okay, we go down here. The nucleon number of element Q is 27. Given that the nucleus of atom Q consists of 14 neutrons. Nucleon is going to be what? Proton plus neutron. So proton is going to be nucleon minus neutron. Okay? So, what's that going to do? So, what they want? What group should element Q be placed in? Okay, find your number of proton dulu. Why? Because it's a neutral atom. Atom of an element. Remember, in the periodic table, we don't directly show you ions. We don't directly show you cation, anion molecule. No. We only show you the pure atoms of elements. So everything in the periodic table is neutral. So your number of proton will be the same as your number electron. So this is your proton, same as your electron. And then, what else? Your number of proton is 13. So your shell is going to be for your electron 2, 8, 3. 3 valence. 3 valence means group 13. You don't need to know this formula actually. Just remember what I taught you here. Okay? This one cukup already. That's why I said you guys can skip this part here. Okay, now let's move on, okay? Let's go to something a little bit different. Okay, element R is placed in group 15. So R, group 15, period 3. What is the electron arrangement for R? How to know the electron arrangement? Period 3. Confirm going to have 3 shells. Group 15 means 5 valence electron. 5 valence, 3 shell. So confirm 2, 8, 5. You guys understand or not? I can't see the thumbs up. Do you guys understand? Rishabh, okay, bro.
Okay.
All right, okay, Chun. This one we do during the break later. I give you all a break. Okay, let's move on to elements of group 18 first. Okay, so my target for tonight, we finish group 18 all the way until group 1. So then this one, group 17. What's next? Let's see. Period 3 and transition elements, we finish in the next class. So we split it in half lah. Okay, so now we start with group 18 group. Guys, group 18 is super duper easy. Trust me lah. Group 18 is easy. Why? Because they are the laziest elements you will ever meet. They are called noble gases. Another name is inert gases. Inert why? Inert because they don't react with anything. The word inert means reactionless. Now, look here, they are found monoatomically. Means like chlorine macam ni, oxygen macam ni. But helium gas is forever he. You won't see the Michael Jackson he, okay? No such thing. Helium is all on its own. Neon all on its own. Argon all on its own. Why? Because they already either have, you look at helium, proton number is 2. So, the shell also 1 only. So, electron number also 2. So, this is stable duplet arrangement. Now look at, let's say neon. Neon period 2. Period 2 means 2 shell. First shell 2. Second shell also cukup makan. Cukup makan berapa? 8. Stable octet arrangement. Because they are stable duplet and stable octet, they are monoatomic. They don't need to combine with anyone. They can exist on their own. Now, this one you need to memorize, okay? Physical properties. Colorless, odorless, insoluble in water, do not conduct heat, low, blah, 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 blah. Why? They're boring, bro. They don't react with anyone. That's why. Because they don't react. So all their physical property, damn boring. Now here's common sense, Going down the group, proton number increase, number of shell also increase, the number of electron also increase. When the shell increase, the electron increase, atomic radius also increase. Now, when size is bigger, increasing atomic size, then forces, what? Van der Waals forces of attraction become stronger. So when the intermolecular force, the Van der Waals force becomes stronger, you need more heat energy to overcome the forces of attraction between atoms. So if this is helium, like that. This is neon, like that. This is, let's say, argon, like that. You guys understand what I mean? You're going to need, it's going to be stronger, the bonds. So maybe here your API is like that. Here your API like that. Here your API like that. You get what I mean? Guys, if clear means please react. Okay or not? Okay. Now, what happens when the force of attraction increase? Boiling point increase and density also increase. Why density increase? Because the mass is increasing quicker than the volume. Because the atomic mass is increasing quicker than the atomic volume. Why? Because density is mass over volume. Okay, now let's move on. What I told you, they are chemically inert. So chemical properties, nothing much. What I told you, duplet electron arrangement. Then here, octet electron arrangement. Do not donate, do not receive, do not share. They are monoatomic and chemically inert. That is chemical property. Senang je. Now, the uses of this one, you have to memorize yourself. I'm not going to read through, sendiri baca. Very straightforward. They will ask, okay, in exam. Don't think they won't ask. They will, I can guarantee you. Okay, all clear or not? Because I want to move on to elements in group 1 already. All clear? People, okay, bro. Okay, Chun. Alright, so group 1 is known as alkali metal. This is the name. Guys, this one you have to memorize. Always remember the name of the atoms. I recommend. At least you kena tahu sampai potassium. Okay, at least sampai potassium you kena tahu. Group 18, all you have to know. But like I said, if you want to be completely safe, okay, if you want to be completely safe, just memorize the names of the atoms in the group. All the atoms in the group. Some spelling problem, Francium is this. Because it was discovered in France. You can go Google it. So in English, this is the correct spelling. Okay, physical property dulu. Okay. Alkali metals exhibit metallic properties. Grey solid with shiny surface. Okay. Conduct heat, conduct electricity. Metal ma. They are also soft metals. Can easily cut using small knife. They have a low melting and boiling point. Okay. Low melting and boiling point. Which decreases down the group. Why? I'll explain to you all now. Low density. Okay, we go through this. Low density. Lithium, sodium, potassium float on water. Because density is smaller than water. Okay, guys. Why the melting and boiling point decreases down the group? Why? Because I want you to imagine like this. This guy is doing charity. Okay, all these atoms are doing charity, okay? They are making donations. But this fella is poor. Semakin bawah you pergi the group, okay? Semakin kaya the fella. So this fella last year will be rich. Why am I using this analogy? Because these atoms have one valence. This one valence electron will be donated. So, at the top here, the melting point is high. So high melting point. Why? This fella, you can imagine he's saying, hey bro, I got money but I don't feel like giving lah bro. So high melting point means high heat energy. That means you need to pujuk him banyak, okay? You pujuk him banyak, then only he will donate. This fella, the melting point, maybe around here only. So he's like, hey bro, I got money but not sure what to do with the money bro. Okay? So this one you don't need to pujuk so much. You put in this amount of heat energy, it will overcome the melting point and the forces of attraction and it will donate. Okay? Then last one, this fella also, satu saja valence. He's saying, Dave, you look at me, I already top pair, damn fat here. Can help me lose weight or not? Just take my money bro, take my money. So this one, the melting point, sikit saja. Just a little bit of heat energy and boom, this fella going to react. So, I give you one molecule, one very common molecule that will react in your daily life with alkali metal, which is oxygen. You want to combine this fella with oxygen, you need a lot of heat energy because he got money, but he don't want to give oxygen. This fella, this one, you don't need to heat up with oxygen. You need heat, but not that much. You heat a little bit, he will bagi. Okay, this fella, you tak payah nak panaskan pun, boom, it will give oxygen already. So what does that tell you? That means as you go down the group, the reactions get more and more explosive, more and more violent. Okay, so group 1 metals you cannot mess around. Even potassium also, right? You react in a, you will learn that experiment later. Group 1 alkali metal in water, right? This is your water, you put on potassium there. Wait, if you put too much potassium, right? It will react so violently to a point that your entire container will kaboom. The whole thing will explode. So group 1 metals, we have to be careful. Okay, so look here, melting, boiling point, hardness decrease. Atomic size of alkali metal increases, causing strength of metallic bonds to become weaker. Why? Let me explain this to you. Cuba bayangkan like this, okay? We got 15 minutes left, by the way. Okay, so what I want to explain to you all right now. Imagine the Li, the lithium, that is your nucleus, that is your valence here. So nucleus, this one valence. Look, they are very nearby. So the forces of attraction between the nucleus and the electron is strong. Here, this one is your nucleus, this one is your valence. Tengok, the distance increase. So the forces of attraction between the nucleus and the electron turun sikit. This one, pai, I don't need to say anything lah. This is your nucleus, your valence is maybe here. Look at that. The forces of attraction between your nucleus plus the electron, valence one, lagi sikit. So, here, kedekut. Because the bond is very strong, the force of attraction very strong. Here, not so kedekut because the force of attraction between the nucleus and the electron getting weaker. Here, this fellow multi-millionaire anyway. He's giving his money basically just to write off his tax exemptions at this point. He's that rich. So, the forces of attraction is damn weak. You put a little bit of energy also, boom, this electron will fly and go and kiss the oxygen already. You guys can understand or not, the analogy I'm trying to use? Okay, so I will write the proper explanation here. As the atomic radius increases, okay, the forces of attraction between nucleus and valence electron decreases. This allows the valence electron to react more freely with other compounds and be donated. This causes the melting point and boiling point to decrease as we go down the group. Less energy is required to overcome the forces of attraction between nucleus and valence electron, causing the metallic bonds to weaken. I tell you, you write this in exam, confirm you dapat full mark, confirm. Every exam I will write this answer last time, boom, always my periodic table chapter, full mark, full mark, full mark. Trust me guys. Okay, I'm going to move on. You guys can write this later lah because I'm recording. Okay, now let's go on with chemical properties and all. There, I already explained this earlier. This is exactly what I explained. See, reactivity of group 1 increases by proton number increase, number of shell filled with electrons increase, atomic size also increase. Atomic size, atomic radius, same thing. Valence electron further away from nucleus, force of attraction between nucleus, valence, weaker. Bigger size atom release valence electron easier. Electropositivity of alkali metal increases. What is electropositivity? Tendency of an atom to donate electrons. Oh shit, I didn't even realize it was written here. I didn't even realize. See, means I know what I'm teaching. That's how you know that I still remember all my shit from high school until now, you know. Okay, experiments are damn important, especially in this chapter. So, this one is the reaction of alkali metal with water. Okay, this one for your Amali, you study yourself. But I'm just here to explain to you how this works. Okay, lithium moves slowly, surface of water, hissing sound. Colorless solution form, turn red litmus paper to blue. Why? Because alkali metal. So what is the reaction we're actually producing? Lithium plus water. Guys, alkali metal, meaning confirm you're getting a hydroxide. You are confirm getting lithium hydroxide. Now, is this equation balanced? No. Why? One oxygen, one hydrogen. Maksudnya apa? We got one extra hydrogen there. Mana boleh? No such thing. So we need to balance the hydrogen gas. How are we going to get H2 gas now? Okay, let's count. Here we have 2. If we put 2, we will get 4 hydrogen. So 1, 2, 3, 4. Okay, see oxygen 2 ada, lithium 2 tada. So we have to put here 2, and then hydrogen 2 biji sini, 2 biji sini, cukup 4 makan. Now what you need to remember here, okay, what you need to remember is the intensity of each reaction. Damn important. Sodium move rapidly and randomly, hissing sound is heard. Colorless solution form, turn red litmus paper, what? Turn red litmus paper blue. Potassium, by the way, for your sodium, you can add here randomly with small yellow flame. Okay, you can add that. Potassium melts, becomes a sphere, moves very fast and randomly, purplish flame. On surface of water, hissing and pop sound. Pop sound. Guys, pop sound means what? It's coming from your hydrogen gas that is being produced in the reaction. Okay, same thing. Colorless solution, red litmus paper, blue. Why? Why reactivity increase? Why? Because of this. You see now, this is why I said experiments in this chapter are damn important. Because all the concept in the experiment will be tied back to the theory. See? So whatever experiment lah, whether you put it, you bakar with the oxygen ke, or you put in water ke, all will tie back to this theory here. Okay? Now react with oxygen. So react with oxygen. Okay, this one here is its own equation. Now we're gonna have lithium react with oxygen. So macam mana? Lithium, oxygen. You'll get lithium oxide. Why? Why Li2? Because oxygen is 2 minus. Li is 1 plus 1. Meaning, you need 2 of this. So Li, 2. So is it balanced? No. Why? Oxygen ada 2. Sini 1. So least common multiple, 2. Okay, very nice. Lithium now, how many? 4 already. So here you have to put 4. That's how you balance your chemical equation. Theory, look, almost the same theory. Lithium burns slowly, red flame. Thick white fumes, white solid produce. When it is cool to room temperature, colorless solution, red litmus paper blue. Rapidly, bright yellow flame, white fumes, white solid room temperature, colorless solution, red litmus paper blue. And then potassium, very rapidly, blah 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 blah. Read yourself, I malas to explain. Okay, same reactivity here, same theory here. Are we clear or not? If we are clear, can I get some thumbs up, please? Very good. Okay, last reaction. After this, I'm going to give you guys exercises. Then we take a break after that. Okay, last theory for alkali metal. Last theory is going to be reaction of metal with chlorine. Okay, reaction of metals with chlorine. What are we going to get? Look up. Give me 1 second. Okay, lithium, chlorine, lithium chloride, sodium chloride, potassium chloride. Same theory way. Red flame, thick fume, white solid produce, thick fume, white solid, just the color of the flame only changing. If you need me to explain, put thumbs up. If you don't need me to explain, put thumbs down.
So you look at elements in group 17. Okay. That day 4.1 to 4.4 already ran through. I will upload the recording maybe tomorrow or the day after. Right now I'm going to start with group 17 elements already. Okay. So they are known as halogens. Then these are the atoms. They exist as diatomic molecules. Why? Because on their own, their valence electron is 7. They are so close to achieving a stable octet arrangement. So what they do? They'll form a covalent bond. So if this is your, let's say, fluorine 27, and then here you got another fluorine. Okay. I'm sorry. Wait, Now let's say here you have another fluorine. Okay. So what it will do is, okay, these fluorines will form a covalent bond here like this. They will share this electron. Okay, then you get 1, 2, 3, 4, 5, 6, 7, 8 here. And then 1, 2, 3, 4, 5, 6, 7, 8 here. So they exist as diatomic molecules. Why? To achieve stable octet electron arrangement. Okay, then I move on. Now, physical properties. Okay, do not conduct electricity in all states, dull surface, low melting boiling point, which increases down the group. Okay, then you see melting boiling point increases. Why? Because molecular size of halogen increases. When the size increases, the intermolecular forces of attraction also become stronger. This will result in more heat energy being needed to overcome the intermolecular forces of attraction between the molecules. Color of halogen becomes darker. So the molecules are small like this. This is your intermolecular force. The bigger the molecules get, the stronger the intermolecular forces. That is the theory for physical properties. Now, this is important. Handling halogens, okay, they are toxic and easily vaporized. Means what? Easily vaporized. Easily turned to gas. All must be carried out in a fume chamber. Fluorine, very reactive, very toxic. Astatine is radioactive. See, so all these halogens, right, they are very easily vaporized and they are mostly toxic. Okay, so you must remember, whenever you have something to do with halogen, do it in a fume chamber. Okay, now we go on to chemical properties, okay? 7 valence electrons, all right? 7 valence electrons. So what can they do? They can react with water to produce acid, iron to form iron 3 halide, and react in alkali, such as sodium hydroxide, to produce 2 different halide salts and water. Okay, so remember, look here, from 2,7 become 2,8, means it's accepting 1 electron. So it is electronegative. Halogens are highly electronegative. Now, why? Like I told you earlier, to achieve a stable octet electron arrangement. Here, look at that. Okay, now the reactivity decreases when going down the group. Why? Because proton number increase, okay? So the mass of the atom is increasing. So number of shells filled with electrons increases. Atomic size also increases. Valence electrons further away from nucleus. The bigger the molecule, the bigger the atom, the further the valence from the nucleus, Force of attraction between nucleus and valence electron become weaker. Strength of halogen, pull one electron into outermost shell, decreases. Electronegativity decreases. What does that mean? If I give you fluorine, chlorine, bromine. This is my fluorine. Say my valence is here. This is my chlorine. My valence is here. This is my bromine now. Look, the gap between the nucleus and the valence keeps increasing. So it's like, wait, someone try and join? No, okay. So when the gap keeps increasing, right, basically what's going on is, imagine like you have a dog on a leash. If the dog is nearer to you, you have more control to it. The further away the dog goes, the weaker your control is. So in this case, I want you to imagine that halogens are lazy. Why do I say that? Because the further away they are from the nucleus, right, the more they'll feel like, it's okay, I'm happy with my 7. I don't need to look for 8 to go and become valence. But the nearer it is, it's like the nucleus is telling them, go and find a valence electron. Then they say, okay. Then you will go and pull in one valence here. That is the theory behind it. Can you understand, or is there anything you're blur about?
Can understand.
Okay. Electronegativity is the tendency of a non-metal atom, is the keyword, receive electrons into its outermost shell and form an anion, means negatively charged ion. The easier the atom attracts electron, higher its electronegativity. And then, now we go on to the experiments. First experiment, halogen with water. Okay, this one, of course, in your Amali might come out, but here's what I want you to know first. Safety precautions. All these poisonous, wear rubber gloves, safety goggles, fume chamber. Why I want you to know this? Because it can come out where a question will ask you for list 2 safety precautions when handling halogens. So it's better to have this knowledge. Now, look at this. Hydrochloric acid. And then, through this tube, the rubber stopper, here you have distilled water. Why we use potassium manganate 7 crystals? Why? This is damn important. Wait, 1 second. So, the reason we use potassium manganate 7 crystals, right, is because to prevent too much chlorine gas from escaping. So, what it does is, it will make sure that not too much of fumes come out. Because if too much come out, it's going to go into the environment, then you are going to get sick. We don't want that. The chlorine gas comes from where? It comes from the hydrochloric acid. Okay, then this is bromine. Bromine with water is very simple. Put liquid bromine in water, iodine, rubber stopper, you just put iodine crystal in distilled water. Why? Because now we want to compare the reactivity of halogens. Okay, the reactivity when we put chlorine, bromine, iodine in water. Why don't we directly put chlorine gas in here? Try and guess and see. Why we put hydrochloric acid? Why not directly we put chlorine gas? Can you tell me?
Not sure.
Okay, but at least try. Take a guess. Has something to do with this, the safety precautions.
Will it let out some poisonous vapor?
Very close. Very, very close. Let's just polish that sentence a bit. Chlorine gas is very unstable and hard to handle. It will let out toxic fumes. HCl is easier to handle. So basically, the concept you understand already. Okay, liquid bromine, why? Because it's not that unstable. Then last but not least, iodine crystal, why? Why this one solid also can? Because the thing is, at room temperature, iodine exists as solid. At room temperature, bromine exists as liquid, and at room temperature, chlorine exists as gas. So, because it exists as gas, it's very hard to handle at room temperature. So, we put it in HCl form. Bromine liquid and iodine solid. The reason why they are in liquid and solid is because, remember, you go further down the group, reactivity decrease. So, the state of matter also will get easier and easier to handle. From gas to liquid to solid. Can you understand or not?
Yes, can.
Okay, Chun. Now, this is the part you need to know. Okay, the discussion part and the observations. Okay, chlorine gas is greenish yellow, dissolves quickly in the water, form pale yellowish solution. Turns blue litmus paper red and then white. Bromine, reddish brown liquid, dissolves slowly. Yellowish brown solution. Blue litmus paper red and then white. White basically means bleaching. The acid is so strong that it bleaches the litmus paper. Sampai tukar warna terus. And then only a very small amount of purplish black crystals dissolve in water. Form a pale brown solution. Solution does not change blue litmus paper to red or bleach it. Why? Because it's not reactive at all. It's very slow to react. So you want to change color also, not like anything's going to happen. So when you mix chlorine with water, you'll get 2 types of acid. Hydrochloric, hypochlorous. Anything got O inside, right, will turn it into a bleaching agent. This is just your standard acid. This is your acid that's so strong that it can bleach things. Okay. Got anything which you don't understand or not?
No. All I
Okay.
understood.
All clear?
Okay.
Okay, good. Now, halogen with iron. Okay, why halogen with iron? What is the purpose of soda lime? Can you tell me the purpose of soda lime or
To absorb the excess halogen gas.
not? Correct, okay. Okay, nice. Then, look, same thing. Too dangerous to handle, so we put it like this. We put it in liquid format. Then this one, liquid bromine, and then this one, iodine crystals. Okay, now, what happens? See, we heat all of these. Except for this one. This one don't even need to heat. Why? Because it's already very reactive. This one need to warm a little bit. This one you need to heat strongly. Why? Because it's based on the reactivity. Okay, now, when you react any halogen with iron, you will form a brown solid. That is the first thing. Then, based on the halogen, okay, based on the halogen, what you will get? Either glow brightly, moderately bright, or dimly, based on the reactivity. So this is your reaction. 2 iron here. 6 chlorine. 2 times 3, 6. Because your iron charge is positive 3. And as I said, you go down, reactivity decrease. I'm assuming this one also you can understand quite easily.
Yes.
Okay, good. Then we go on to chlorine with cold sodium hydroxide solution. Okay, sodium hydroxide. What's going to happen when we react? Okay, let's take a look. Same setup. The only thing is this one, we put rubber stopper, and this one also rubber stopper. Okay, what do we get? Greenish yellow gas, dissolves quickly, colorless solution. Reddish brown liquid, moderately fast, colorless solution. Purplish black, slowly, colorless solution. Same thing, reactivity down, solubility down when the molecule size increase, blah, blah, blah. Okay, now, let's take a look here and see what we produce. We produce 2 types of salts, okay? When you put a halogen in an alkali, you produce 2 types of salts. Sodium chloride, chlorate. Bromide, bromate. Iodide, iodate. Is there anything which you are not sure about here?
So far, no.
All okay, yeah?
Yes.
All right, okay. I will finish teaching until 4.7 first. Then you do the exercises, can or not?
Can.
Okay, sure. So I start 4.6, huh?
Yeah.
All right, okay. Now, all this while we've been learning groups. Group 1, Group 2, Group 17, Group 18. Oops, sorry, 18. Now we're going to learn period. For example, period 3. So we're learning across now. We're not going down, we're going across. Period 3. Third horizontal row from the top. So hydrogen is up here with your 1. And this is your period 2, this is your period 3. Okay. Now, these are the elements. All elements found have 3 shells filled with electrons. Okay, so period is basically the number of shells. Number of electron shells. Can you understand?
Yeah.
Okay, now this is the key part which you need to know. Okay, as you go down the group, the number of proton will increase because that's how the periodic table works. The positive charge also will increase. See, when the positive charge is increasing and the electronegativity is decreasing, sorry, electropositivity is decreasing. Electropositivity decrease, electronegativity increase. Can you take a guess and tell me why?
Is it because the attraction force?
Kind of. Try again.
The number of proton increases.
Half answer. Okay, that's half. Yes, when the number of proton increase in an atom, the number of electron also will increase, correct or not?
Yes.
Okay, so when is it easier for an atom to donate electrons? When it has less valence to donate or more valence to donate?
When it has less.
Correct. So you look, as you go down the group, you go from 1 valence to 2 valence to 1, 2, 3 valence, and so on and so forth. As you go down the group, your number of valence electron increase. So your tendency to donate valence electron will decrease, correct or not?
Yeah.
So your electropositivity goes down. Your electronegativity goes up. Why? Because, look here, you are getting more and more valence. When you get more and more valence, it's easier for you. I want you to imagine, this one is closer to 0, this one is closer to 8. Meaning what? Meaning here we are looking to get rid of this entire shell. Here we are looking to fill the entire shell. So chlorine is -1. Sulfur -2. Phosphorus -3. Sodium is +1. Magnesium is +2. Aluminium is +3. Silicon is nothing. Silicon is neutral. Because silicon is obviously +4, -4. It's a semiconductor. It can go both ways. You understand what I mean?
Yes.
So we abaikan silicon for a while. We don't look at silicon for a while. So you look at for +1, +3, it's easier to go to 0. For -1, -2, -3, it's easier to go to 8. Correct or not?
Yeah.
So the goal here is to fill up the shell. The goal here is to remove the shell. Can understand?
Yes, it can understand.
Okay, give me 1 second. Okay, now, when moving across period 3 from left to right, okay, number proton increase. So, positive charge in the nucleus will increase. Nuclear attraction towards electron becomes stronger. So, when you mentioned that, you were half correct. This is what I meant. That half you told me already. Then, electrons pull closer towards the nucleus. Now, because of that strength between the nucleus and the electrons, it's pulled closer. So, the atomic size decreases. Then what? The tendency of an atom to attract electrons into the outermost shell, that means electronegativity increases. Why? Because all this we want to fill up the shell. So that means we attract into the shell. So these are your changes in physical properties. Now we take a look at chemical properties, what's going on. Okay, when we look at period 3, we like to look at period 3 as oxide compounds. Like that's our gold standard to determine if it's a basic period 3 element, an amphoteric period 3 element. Wait, somebody joining. Okay, so like I was saying, when we look at period 3, okay, our goal is we want to see if it is a basic period 3 atom, an amphoteric period 3 atom, or an acidic period 3 atom. How do we check that? We check that by turning it into an oxide. So the first 3 are metal, the last 4 are non-metal. Bro, why we don't have any argon oxide? You see, we managed to have sodium, magnesium, aluminium, all of that. Why argon we don't have? Can you tell me? It's period 3, but why isn't argon there?
It already achieved stable octet electron arrangement.
Bingo. Because it's already full mass, so the further don't need to go look for more. So you don't need to react also. Okay, then type of oxide. Basic, react with acid. Amphoteric, react with acid and alkali, produce salt and water. And then this one react with alkali to produce salt and water. So all of these, right, they are going to react and produce salt and water. Just depends what it reacts with. Basic with acid, acid with alkali, amphoteric both ways also can. So these are the reactions. I think if you've already attended my Form 4 Chapter 3 class, or even if you haven't attended, if you watch my recording, I don't need to teach you how to balance the equation. You just read this yourself when you are free. Okay, then we move on. Okay, this one all already explained. Okay, now to study the change of properties of oxides of elements across period 3. So this one, what we're going to do? The first one, this is a basic oxide. Sodium oxide power, what we're going to mix it with? We're going to mix it with nitric acid, or we're going to mix it with sodium hydroxide solution. So we're going to put sodium oxide in here. We're going to put sodium oxide in here, see where it reacts. Then we change. We put magnesium oxide in both, see where got reaction. Put aluminium in both, see where got reaction. Sampai lah we reach chlorine. So what is the purpose? See? We want to check. What does it react with? Let me find Okay. White powder dissolves in water to form a colorless solution. This is in water. So when you directly mix with water, you get all this. Now, if we look here, only these two dissolve in water. After that, when you move here to the middle, it doesn't dissolve in water. Then here it will start back again. Colorless solution, dissolve in water. And slowly, you see, until you go back to chlorine dichlorine heptoxide. Okay, now this one, we want to compare what happens when you mix this with nitric acid now. See, so in water, you can determine what? In water, you can determine whether the blood is basic or amphoteric or acidic. Now, with nitric acid, what can we determine? Aluminium with nitric acid dissolve colorless solution. With sodium hydroxide dissolve colorless solution, meaning it is amphoteric because acid alkali both also he will whack. Magnesium oxide is basic. So with an acid, it dissolves. With hydroxide, it has no change. So that means in alkali plus alkali, nothing. Alkali plus acid, you get salt and water. So basic oxide. Then this one, acid plus acid, no change. Acid plus alkali, dissolve colorless solution. Silicon 4 oxide is an acidic oxide. Anything which you are not clear about or not? Both of you. If all clear means, can you all spam some thumbs up? Okay. Then the discussion part. I think I've already discussed this essentially, but I'll just go through briefly. Alright, sodium oxide dissolves readily in water and magnesium oxide dissolves slightly. Okay, that means what? Sodium oxide and magnesium exhibit metallic properties. Okay, then aluminium insoluble in water. Then we go back to phosphorus. So see, aluminium, silicon insoluble in water. Phosphorus, sulfur, dichlorine able to dissolve in water again to form acidic solution. Okay, now we look at the amphoteric properties. All acidic oxides can dissolve with alkali to form salt and water. So acid plus alkali, salt and water. Basically everything which I've already discussed just now. Now, these equations, for the sake of experiment, they may ask you to balance. So I recommend you know these equations, so I recommend you know what you're writing. It will help you out then. Okay, then let's move on before we dive for 4.6. Then later it's 4.7. 4.7 is very brief for me. So let's finish off 4.6, okay? Now we are taking a look at period 2 pula, okay? Located at the second horizontal row from the top, okay, these are the elements. Why is it period 2? Because 2 shells filled with electrons. Simon, remember just now I wrote and I said the period number is the number of electron shells, remember that?
Yes, remember.
Exactly. So moving across, physical state change from solid to gas. Atomic size decrease, melting point and boiling point also decrease. Okay. Let's see the similarities with period 3 pula. Here also, if you look properly, it changes from solid to liquid and then to gas. For example, if you look at argon is a gas what? Chlorine is a gas what? Then later your sulfur can be anything. Your sodium, magnesium, aluminium, silicon, all that, solid. So when you go across, it changes. Okay. Now, this next part is important because it's about your semiconductor stuff. Okay, semi-metallic element is an element that exhibits both properties, metal and non-metal. The name is called metalloid. Okay, they are located in between metallic, non-metallic elements. So these are the elements: boron, silicon, germanium, arsenic, all this stuff here. The main ones you need to know is this boron, silicon, germanium, arsenic. Normally these are need to last you. Okay, then you look here. Silicon, germanium, they are metalloids found in period 3, period 4. What are they used for? microelectronic industries. They have electrical resistance between conductor and insulator. So right, these metalloids, they can be used to form what? Semiconductors. Why? Because semi means what? In between. So they're in between conductor and insulator. So semiconductor is what you find in your AMD, your Intel chips and all of that. Okay, germanium has very high electrical conductivity at a certain temperature. Hence, germanium is another ideal element. Okay, see what is it used for? To make diode, transistor, microchips. Germanium for what? Improve efficiency, solar panels. Okay, last but not least, we go on to transition elements. So we're going to finish this chapter already now. Okay, let's get it over with. Okay, transition elements are also known as metallic elements. Group 3 to 12. Alright, they are known as transition metals. Don't care like you call it transition element ke, transition metal ke, all are acceptable. They are metals, so the properties are metallic. So what? Good heat conductor, electrical conductor, high density, tensile strength, blah blah blah. The typical metallic stuff. Okay, special characteristics. They have more than one oxidation number. So like iron, it can exist in 2+ or 3+. For example, sodium is a metal. It's a metal, but it cannot what? Sodium can only exist in 1+. Iron, no. Iron is special because it's a transition element. See, copper is the same thing. Manganese is the same thing. So they have more than one oxidation number. Some more what? They can form colored ions and compounds. If you look at alkali earth metals, their colors are all grey and dull and like colorless. But if you look at this one, if you look at transition elements, their metals are colorful. Okay, number 3, can act as a catalyst. You will see this a lot. What type of catalyst you will find? See, vanadium 5 oxide, copper 2 sulfate, iron as a pure catalyst. A lot of these, like another one, potassium manganate 7, oxidizing agent. So they can act as a catalyst. Lastly, complex ions. This one you don't need to know that much. You just need to know what a complex ion is. You don't need to know too deep. So what a complex ion basically is, right? Means that if this is your normal ion, okay, like this, a complex ion is what happens when you combine a metal and a non-metal, but it is still having a charge. It's not neutralized yet. Normally metal and non-metal will neutralize each other, right? But not in this case. In this case, this is an anion. See? Sorry for the photo being a bit blurred, I'm not sure why, but basically that's what it means when it says complex ion. Okay, now the use of transition elements is also important. Widely used for what? See, iron, catalyst in the Haber process for production of ammonia, platinum, Oswald process for the manufacturing of nitric acid, vanadium 5 oxide in the contact process of manufacturing of sulfuric acid, and then nickel or platinum, manufacturing of margarine from the hydrogenation of vegetable oil. You will learn more about this in your Form 5 Chapter 2, saturated, unsaturated fats, all that. Okay,